We all love the apple. It's crisp, it's sweet, it's pretty much a global symbol of health. But lurking out there in the orchards, there's this microscopic enemy that can turn that perfect fruit into, well, something pretty awful. We're talking about apple scab. And its story is this incredible tale of survival and, honestly, pure destruction. So let's get into it.
First off, let's just remember what we're talking about here. What's at stake? The apple isn't just some tasty snack. It is packed with nutrients, and it's the foundation of this huge agricultural industry. I mean, think about it. From the pies on our tables to the juice boxes for our kids, it's something we really want to protect.
And then you see this. It's such a dramatic change, right? From that perfect, healthy apple to this. It's blotchy, it's blackened, it's basically ruined. This right here is our crime scene. And the big question is, what on earth could cause this kind of damage?
Okay, so let's start our investigation. We're going to examine this crime scene and really get a handle on just how bad this blight can be.
This quote really says it all. This isn't just some small-time problem for people with an apple tree in their backyard. We are talking about the single most significant, most damaging disease for apple production on a global scale. The stakes, they really couldn't be any higher. And if you want to put a number on that threat, here it is. In a really bad year, in an epidemic year, apple scab can wipe out up to 70% of an entire harvest. For a grower, that's not just a setback. That's an absolute economic disaster. So where does the attack start? Well, it's actually pretty subtle at first. You'll see these kind of velvety, olive green spots on the leaves. They have these fuzzy, undefined edges. But it doesn't stay subtle for long. Those spots get darker, the leaves start to turn yellow, and eventually, the whole tree can lose its leaves way too early, which just weakens it for the next year. And of course, the fungus is after the main prize, the apple itself. The spots on the fruit start out looking a lot like the ones on the leaves, but they turn dark and corky, almost like a scab. And while the lesions themselves are on the surface, they make the apple completely unmarketable and can even cause the fruit to crack wide open. All right, so we've seen the damage, and it is extensive. Now it's time to pull back the curtain and identify the perpetrator behind this whole agricultural crime.
So here it is. The culprit has a name, Venturia inaequalis. It's a type of sac fungus, and you have to admit, it's a brilliant strategist. Its entire life is built around this devastating 1-2 punch that's designed for maximum infection and spread.
And this shows you its two-pronged attack perfectly. The first weapon in its arsenal is the spore. You can think of these as the initial invasion force, the paratroopers that launch the main attack every spring. But once they get a foothold, the fungus unleashes its second weapon, conidia. These are like the reinforcements, launching wave after wave of secondary infections all season long.
And here's a pretty cool little fact for you. The name inaequalis literally means unequal. Why? Because its spores are made of 2 cells, and one cell is smaller than the other. Under a microscope, it gives them this really unique kind of footprint-like shape. Okay, so now that we've identified our culprit, let's break down its MO, its highly effective and very devious method of attack. Now this is absolutely crucial. This fungus, it lives a double life. In the fall and winter, it's a saprophyte. It's basically a scavenger, just feeding on dead, fallen leaves on the orchard floor. But when spring hits, it switches modes entirely. It becomes a parasite, a hunter, actively attacking the living apple tree. So let's walk through this cycle. It all starts in the winter. That's step 1. The fungus is just hanging out, developing inside those fallen leaves. Then, step 2. Spring arrives. You get some rain, the temperature gets above freezing, and bam, those ascospores are released. The wind carries them up to the brand new leaves, but here's the catch. They need at least 9 hours of the leaves being wet to actually germinate and infect the tree. Once that happens, we're at step 3. You start seeing those visible lesions. And finally, step 4. Those lesions become little spore factories, churning out millions of those conidia spores that just keep spreading the disease all summer long. And this right here, this is the absolute key to its survival. That pile of old leaves from last fall, it's not just harmless yard waste. It's the perfect incubator. It's the overwintering hotel for Venturia inaequalis, making sure the whole epidemic can start up again next spring. So, now that we know its life cycle, how in the world do we fight back? And what happens when the fungus has even more tricks up its sleeve? Well, the fight gets complicated because this fungus has some sneaky late game tactics. You've got pinpoint scab, which comes from infections late in the season. But even more deceptive is something called storage scab. This is when an infection was so tiny at harvest time that nobody saw it, but it keeps developing in secret, only showing up after the apple has been put away in storage. Talk about a nasty surprise.
When it comes right down to it, managing apple scab is all about one thing: breaking that life cycle. The single most effective thing you can do without chemicals is just good sanitation. Raking up and shredding those fallen leaves in the autumn can destroy over 90% of the fungus's winter home. Now, fungicides are also an important tool, but they have to be timed perfectly with the weather, the right temperature and leaf wetness. That's why many growers use predictive models, like the modified Mills table, to know exactly when to act. But really, the key to it all is just constant monitoring, catching the very first signs of trouble before a small problem turns into a 70% crop loss. It's really amazing when you think about it. A single microscopic fungus can cause so much chaos and economic damage. It just makes you wonder, what other invisible battles like this are being fought every single day, just to get the food from the farm onto our plates?